Question 12. Show that the integral of x cubed ln x dx is equal to a e to the 8 plus b between 1 and e squared, where a and b are rational constants to be found. Since my two products are x cubed and ln x, neither of these can be written as the derivative of the other, so I can't use substitution, and in fact in this case it's going to be an integration by parts. And so when integrating by parts, if I'm integrating two functions, I'm going to let one be u and one be the v differentiated, and it will equal uv minus vu dash dx. So I'm going to let u equal ln x, and I'm going to let v dash equal x cubed. And the reason I'm doing that is because I can't integrate ln x easily, but I can integrate x cubed easily. And so your choice in this case is important. And so given that u is equal to ln x, I can differentiate that, and the derivative of ln x is 1 over x. Given that v dash is x cubed, I can integrate that, increasing the power by 1 and dividing by the power. V is equal to a quarter x to the power 4. So now my integral has become uv, which is a quarter x to the 4 ln x, minus the integral of quarter x cubed dx. Now this, of course, I can integrate, and so my full expanded integral is a quarter x to the power 4 ln x minus this integral, increase the power by 1, divide by the new power. This integrates to 1/16 x to the power 4. And this is all between e squared and 1. And so when we have a definite integral, first we substitute in the e squared, and then we subtract substituting in the 1. And so substituting in e squared, I've got a quarter of e to the 8. Ln of e to the 2 is 2. So I've got a quarter of e to the 8 times 2. Subtract 1/16 of e to the 8. And then that's all subtracting, substituting 1 into this. Ln of 1 is 0, so this term goes to 0. And 1 in here is negative 1 over 16. Simplifying this, we've got 7/16 e to the 8 minus 1/16 is plus 1/16. So my a is 7/16 and my b is 1/16.